welcome back. Today we will be discussing about interfacing of LCDs. LCDs stand for liquid crystal display. As you may be knowing, liquid crystal displays are usually used in embedded systems for displaying various messages. In this class, we will be discussing about interfacing of these LCDs with our 8051 microcontroller. So far we have discussed about interfacing of LEDs and interfacing of switches. In those cases we only discussed about the hardware interfacing. We didn't write any programs because I believe we have already written a lot of programs related to switches and related to LEDs. In this case, in case of LCDs, we'll be first discussing about the hardware interfacing of LCDs to 8051 microcontroller, and after that we'll be writing programs that will demonstrate how to display messages on these LCDs. The simplest of the LCDs, the ones I will be discussing in this class, is known as something like as 16 into cross LCD, 16 cross 2 LCD. Why is known as 16 cross 2 LCD? It's an LCD with two rows, row 0 and row 1 I may call them, and in each of the rows I can display a maximum of 16 characters, from character 1 to character 16. Similarly, in row 1 I can display 16 more characters. These characters can be alphabets, these characters can be numbers, or some special characters. These LCDs usually have 8 data pins, D0 to D8, D0 to D7. These data pins are used to send data to the LCD. Apart from these 8 data pins, these LCDs also have 3 control signals. One is known as RS, the second one is RW, and the third one is enable. RS is actually register select. Basically, in an LCD, inside an LCD, there are two registers. One register, two 8-bit registers. One register is known as data register, and another register is known as command register, CMD register. Any data we send to LCD using D0 to D7 pins gets either stored in data register or to command register. If RS is equal to 0, then data will be stored in command register, in this register, and if this RS is 1, then this data will be stored in data register. If the data is stored in data register, it will be displayed on the LCD screen, and if there is some data that we are storing in command register, what will that data do? That data is actually commands for the LCD. Commands in the sense, maybe for example there will be a command that will clear the contents of LCD. Anything that is written on LCD will be cleared by that command. There are many more commands. We'll be discussing those commands in next few lectures. Apart from this, we also have RW. This is actually read and write. We can read data from these registers to the microcontroller, and from microcontroller we can write data to these registers. If it is 1, RW pin is 1, that means we are reading data from the registers. If RW pin is 0, that means we will be writing data to these registers using our microcontroller. And then there is the third command signal, that is enable. What does enable do? Once we have chosen a register using register select command, and thereafter we have chosen, do we want to read into that register, read from that register, or write into that register. After these two steps, we need to send a high to low pulse, high to low pulse on this pin, so that if the data is in data register, this data gets written on the LCD, gets displayed on the LCD. And if the data is in the command register, that is, we have earlier chosen command register, this data does some job like clearing the LCD or moving to a specific position in the LCD. So in a typical 16x2 LCD, we have 8 plus 3 11 pins. Apart from these 11 pins, we have 3 more pins for power supply. We have 2 pins VCC and ground for power supply, and then there is a third pin. To this pin, to VCC pin, we'll be giving plus 5 volts, to ground 0 volts, and then the third pin is known as contrast pin. We can give any voltage from 0 volts to 5 volts to this pin. This will determine the contrast of the LCD. If we will be giving 0 volts, the contrast will be at full, and if 5 volts, there will be 0 contrast. So we choose using a potentiometer, we give some in between voltage from 0 to 5 volts to this pin. So we have discussed 14 pins of this LCD. Apart from these 14 pins of LCD, some LCDs might have 2 more pins. These are for backlight. One VCC and another one as ground. Let me show a diagram of a 16x2 LCD here. Here you can see the LCD, 16x2 LCD. It has got 16 pins. Pin number 1 as VSS, where our plus 5 volt goes. Pin number 3 VEE, where our ground goes. And then we have pin number 2 known as VDD. Actually, this is for the contrast. We can give any voltage from 0 volts to 5 volts to this pin. And then we have RS, RW and E as enable signals. We have discussed these signals. And then we have 8 data pins through which we send data to the LCD. That data either gets displayed on the LCD or does some job like clearing the LCD or moving to a specific place. That depends upon the register we have selected using pin number 4. And then at last we have pin number 15 and 16, LED anode and LED cathode, usually known as LED A or LED K. These are used for backlighting the LCD. So moving on, let me try to connect this LCD to my microcontroller. How we usually connect this LCD to the microcontroller. In an 8051 microcontroller, so simply we have, first of all, we have to connect 8 data pins. We have to connect 8 data pins of data that we usually connect to any of the ports. Maybe we are connected to it to port 1. Then we have 3 more control signals that also we need to connect to the microcontroller. 3 control pins. These 3 pins we connect to some other port of microcontroller. Maybe I will connect it to port 2. P2.0, P2.1 and P2.2. So let me try to connect this to my microcontroller. These are data pins. So this may be my port 1, D0 up to D7. So sorry, D7. Okay, D0 will go to P0, P1.0 and D7 to P1.7. Then I have three control signals RS. These data pins are connected to port 1 and they are bidirectional in nature. That is, either data can be sent to the LCD or also data can be read from the LCD. These control signals are S unidirectional. Only the control goes from microcontroller to the LCD. RS is here. This is RS and this is port 2.0. And then we have R slash read write, actually, that we will connect to port 2.1, pin 2.1. And then we have another pin known as enable that will be connected to pin 2.2. This is another pin, that is VCC, will be connected to VCC. And then we have ground here. And then we have the contrast pin. How we usually connect a contrast pin? We usually connect it using a potentiometer. We connect a potentiometer between VCC and ground, and its central leg is usually connected to VDD. By changing the resistance of this pot, we can change the voltage that is delivered to VDD, and hence the contrast of the LCD. And then we have two other pins, LED K and LED A. They are connected to, one is connected to positive and one is connected to the plus 5 volts and another is connected to ground. The purpose of these two pins is to backlit the LED.